Hi, welcome to another class with Fast Academy. This is something that a lot of you requested for, and I thought it's important for me to put this up. This is the IUPAC Nomenclature in Organic Chemistry, which is going to serve as a fundamental concept for you to name any organic compound. First, let me look into some of the history of certain organic compounds. Let's take a very popular acid called formic acid. Now, if you go back to how formic acid even got its name, it got its name from red ants, because every time a red ant stings you, it injects formic acid into you, and in a native language formic acid was derived from the word formicus, which meant red ants. Similarly, we have another acid which is very popular, and this is called as acetic acid. Just like formic acid, acetic acid also got its name from a source which was vinegar, where we find a large quantity of it, from a local language that used the word acetum. And that is how acetic acid came into existence. Now there was a problem. As in when many more compounds were being discovered, it was important for us to understand their source. And once we had to understand their source, they came with several names. And it was really difficult to remember all the names, and that became a huge problem, which is why IUPAC said that there has to be a standard to name all these organic compounds, and that is how the IUPAC nomenclature came into existence. As I said, IUPAC is a standard used to name any organic compound without using any reference to its source at all. Alright, so let us see how this is going to work. Every IUPAC nomenclature has a format, and the format is going to be divided into three parts. That's part 1, part 2 and part 3. Part 1 refers to a point called as prefix. Second part is known as the root word, and the third part is known as the suffix. Now what does prefix indicate? Prefix has everything to do with something known as substitutes, which we will talk about a little later. Root word has connections with the total number of carbon atoms in the longest carbon chain, which again we shall revise in a couple of slides from now. There you go. And suffix has something to do with functional groups, which are known for their properties to change the overall nature of the compound itself. Alright, so let us understand each one in detail so that you're in a position to appreciate and understand the topic much better. First, let us understand the meaning of substitutes. Substitutes are anything that are attached to the carbon chain, and there are several examples of what it could look like. The most common thing is represented by R and is known as the alkyl group. And under alkyl group, you have several groups that can be used. One is called as the methyl group, which is a derivative of methane. Mind the spelling, methyl. Another group is called as the ethyl group, which is C2H5. And then you have C3H7, which is going to be the propyl group, and so on. So this comes under one category of substitutes. We have another very popular substitute called as the Hallow group, or the halogen group, represented as X. And since we know all the halogens would include a chloro, a bromo, a fluoro, and an iodo. This would be fluoro. The last one would be iodo. Now, apart from the given groups, you could also have other groups, which are the NO2 nitro groups and the NH2 amino groups. So what we have written here are all the names or the prefixes that you would use to substitutes, which would be these groups that we are circling right now. You have bromo, fluoro, iodo, nitro and amino, and these come under the family called prefix, which I have just highlighted for you. If you can remember this page, it will help you answer most of the substitutes, or you will know what prefix you will have to put in their name. Now that we have understood this, let's move to the next part of it, which is called as the word root, sometimes also referred to as root word, so please don't get confused when they use the interchangeable terms. Now word root indicates the total number of carbon atoms that are present in the longest carbon chain. So to help you understand how the word root is going to look like, I'm going to make two columns for you. One to indicate the total number of carbon atoms in the longest chain, and the second to indicate the word root. So I'm just going to quickly list down the number of carbon atoms from 1 to 10. You could also stretch this beyond 10, but to restrict it to our study within the syllabus, we're going to keep it to 10. If it is 1, the word root is going to be meth. If it is 2, it is going to be eth. 3 would be prop. 4 would be bute. 5 would be pent. 6 is hex. 7 is hept. 8 is oct. 9 is non, and 10 is dec. Similar to how you would name your polygons, you have a 5-sided polygon which is called a pentagon, and a 6-sided is a hexagon, and so on. So if you can just remember those two charts, it will also help you understand the third part of it, which is your suffix, which is applicable to your functional groups. The first one is the alcohol group given by OH and given by the suffix, I'm just going to put that there, as all. The next one we're going to look at is the aldehyde group, which is given by the representation CHO. The suffix for aldehyde is going to be al. The third one is the carboxylic acid group. So please identify these groups as you name the organic compounds. And carboxylic acid is given by COOH and represented by the suffix oic acid. The fourth one is the ketone group, represented by a C with a double bond O, represented as one. You of course have the usual ones too. You have a single bond which comes under the alkane family, and the suffix you are going to use for this is ane. Similarly, you also have a double bond for alkenes, represented as enes. And the last one is for the triple bond, which is for alkynes, represented as ine. Now that we have understood what comes under prefix, root word, and suffix, let us try and name and figure out how we could bring in that IUPAC nomenclature to any organic compound. So let me take an example first. Let's take CH3, CH2, CH, CH2. I'm going to put a Cl there. And now let us try and see how we can work on it. Step 1 is to identify the longest carbon chain. If you notice, the purple chain happens to be the longest carbon chain, so I shall identify it by the green box. In my second step, I'm going to number this carbon chain such that chlorine gets the smallest number. If you see, chlorine is outside my chain, which happens to be the substitute. I need to number it such that chlorine gets the smallest number. So let us see how we could name it. We're going to name it from right to left. In that case, we're going to make sure that chlorine gets 2 as the number. If we number it from the other side, we're going to get 3 as the number. Between 2 and 3, the smallest is 2. So we're going to retain 1, 2, 3, 4 from the right to the left. And finally, in the part of the third step, we're going to name it based on the 3 parts to it. One is the prefix, second is root word, and third is the suffix. If you notice, for the prefix, we have chloro, which is attached to the second carbon atom. So my prefix is going to be 2-chloro. If you identify the root word, there are 4 carbon atoms. So it is going to be bute. If you notice, the functional group only happens to be a single bond, so it's going to be ane. So the final name is going to be 2-chloro-butane. I'm just going to give you a few seconds to absorb this. Let's go into the next example. This is example 2. I'm just going to put that out for you. It is going to be CH3, CH, CH2, CH3, and I'm going to attach another CH3 to my CH group. Step 1 is to identify the longest carbon chain, as I've just written it down. Now if you notice, there are 2 long carbon chains, one that has 4 like this, and we can also have another 4 carbon atom chain like this. Since both have the same number of carbon atoms, you can choose any one to be the parent chain, and I'm going to number it such that the methyl group, which is outside the chain, gets the smallest number, which comes in step 2. So if you look at the orange way of numbering it, you're going to get that right. Now let us name the compound. As I told you, there are 3 parts to it. If you notice, methyl happens to be my substituent group which is attached to the second position, so that's going to be 2-methyl. There are 4 carbon atoms, that's going to be bute. I have a single bond, it's going to be N, so this is going to be 2-methyl butane. Excellent. Let's go to the next one. I have CH3, CH2, CH2, COOH. Now if you notice, COOH is a carboxylic acid group, and that has to be included in my longest chain, which is very important, and that should always get the least number, indicating that you have to start numbering it from the right. If you notice, there's nothing outside the chain, so there's no prefix. 4 is going to indicate bute. I'm going to write butane, and since it's a carboxylic acid, I'm going to put oic acid, so this becomes butanoic acid. All we have to do is from butane, we have to remove the E and put an oic acid to make it butanoic acid. Let's look at another example. CH3, CH2, 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 CHO. If you notice, CHO happens to be my functional group here, which represents an aldehyde. So this happens to be my longest chain. As I said, CHO is my aldehyde group. I need to start numbering always from the aldehyde group. So I'm going to start like this, and I'm going to put the format, the prefix, the root word, and the suffix. If you notice, there's nothing outside the chain, so there's no prefix at all. My root word is going to include 5 carbon atoms, so I'm going to write pentane first. And if you notice, my suffix is with the aldehyde group, so I would put an al, and I would remove the E, and the name I would get would be pentanal. Excellent. Now that we have understood this, let's try another one. Have CH3, CH, CH2, and a CHO. And what I'm also going to do is attach a CH3 group to the CH carbon. Now let us see how we could pull up the chain. There are 4 carbon atoms, which happens to be the longest chain. Please ensure that CHO is a part of your chain. You have to start numbering such that CHO gets the least number. So I'm going to go with 1, 2, 3, 4. I notice that my methyl group, which is my yellow methyl group, is outside the carbon chain, so that becomes my prefix. And since that is going to be my prefix, that is going to be attached to the 3rd position, so that is going to be 3-methyl. There are 4 carbon atoms in the chain, so I'm going to put butane. And since it's the aldehyde group, I'm going to put al and then remove the E. So this is going to be 3-methyl butanal. I hope that was clear. We could go look into another one. Now there are several examples that one could look at, and let us look at this interesting example. I have a CH3, I have a CH, I have a CH2, I have a CH3, and now what I'm going to do is introduce an OH group. OH we know is the alcohol group. Let us first identify the longest carbon chain, which happens to be that. Since OH is a functional group, OH should always get the smallest number. So OH would get 2. Let us start numbering it and writing the names now. This prefix, this root word, and a suffix. There's nothing that is a substitute outside the group. I have a root word, which is going to be bute. I'm going to write it as butane. And since OH is a functional group, that's going to come under suffix as all. And then I'm going to remove the E. And if you notice, I'm going to put a butan all. But if you notice, all is in the 2nd position, so it's going to be butan 2 all. One thing I want you to understand is, if there is a different position for a substitute or a functional group, the number has to be very clearly mentioned in your IUPAC name. Let's try the next one. This is something I want you to try. Let's put up a very simple one for you. CH3, CH2, CH, CH2, CH3, and I'm going to put an OH here. First identify your longest carbon chain, then make sure OH gets the smallest number, and then you begin naming it. So first I'm going to start identifying the longest chain. There we go. that happens to be the longest chain. I have to number the carbon chain such that OH gets the smallest number. Since OH is attached to the middle carbon, it doesn't matter how we're going to number it. If you notice, OH is my functional group, so that's going to come under my suffix. There we go, that is the format. We have a prefix, we have a root word, and we have a suffix. Since there's no substitute outside the chain, I'm going to ignore my prefix. My root word is going to be pent. My suffix is going to be all at the third position. So the word is going to be pentin 3-ol. Sometimes certain books also just call it 3-pentanol. Let's try the next one. CH3, CH2, CH2, CH. Put a double bond there and put a CH2. Now if you notice, if you go back to the functional groups table, you'll notice that double bond also happens to be a functional group with the suffix E. So I've just highlighted it just to tell you where the functional group is. Now what we're going to do is number the carbon chain after identifying the longest chain, but you have to ensure that the functional group always gets the lower number. The next question is, if I have a substitute as well as a functional group, which one should really get the lower number? And the answer again is the functional group. And now that we have everything ready, let us start naming this. Since we have nothing outside the chain, there is no prefix. There are 5 carbon atoms in the longest chain, so my root word is going to be pent. You notice that the suffix is going to be -ene. Since it is between the first carbon atom and the second carbon atom, I'm going to take the smallest number, which is 1. So my answer is going to be pent 1-ene. Sometimes in a lot of books they tend to ignore the 1 and they just call it as pentene, where you can just ignore that 1 altogether. Let's look at another example. The CH3, CH double bond, CH, CH2. I have a CH2 and I have a CH3. Let us try and name this organic compound. If you notice again, double bond happens to be my functional group, so my double bond has to get the least number. So I'm going to number it, and if you notice, double bond exists between 2 and 3. The smaller of 2 and 3 would be 2, so that will be the position of my suffix. So let us put it together now. So the format is going to be a prefix, a root word, and a suffix. There is absolutely nothing outside my chain. There you go, that is my chain, so there's nothing outside my chain, so I'm not going to have any prefix. I notice that there are 6 carbon atoms, so my root word is going to be hex. You notice that there's an -ene as my suffix, and you need to take it at the position 2, because the double bond lies between 2 and 3, and the smallest number between 2 and 3 is 2. So my answer is going to be hex 2-ene, or sometimes just written as 2-hex-ene. Let's try another one. And at any point in time, if you want to make an attempt, make sure that you pause the video, attempt it, and then relook at the video. This is going to be CH3, CH2, CH with an OH attached to it. Okay, hold on. Let's not put an OH there. Let's make it a little simpler first. Let's put a chloro. And then I have a CH and a double bond CH2. Now, if you notice, I have a double bond which is a functional group. I also have chloro, which is a substitute. Between the double bond and chloro, double bond should always get the smaller number, so I am forced to number it from right to left. So if you notice, my double bond lies between carbon 1 and carbon 2, so the position I will have to take is the smaller between them, which is going to be 1. Now that we have the format ready, let's start naming it. Since chloro is a substitute and present in the third position, the prefix is going to be 3-chloro. Since there are 5 carbon atoms in the chain, it's going to be pent. And finally, if you notice, my double bond is going to be in the first position, which is my suffix. So my final answer is going to be 3-chloro-pent-1-ene. And since you can ignore the 1, you could just write it as 3-chloropentene. I hope this was clear. I want you to try the next one, and it's going to become easier as you go ahead doing it now, because you have all the information ready with you. Let's put this out. This is going to be CH2 double bond CH, CH2, CH, CH, put another CH3 next to it. I'm going to put a bromo to one of the carbon atoms and a chloro to the other. And now what I'm going to do is try and identify the longest carbon chain. If you notice, in this I have two substitutes, which is chloro and bromo. I also have a functional group in the form of a double bond. The first thing I'm going to do is identify my longest carbon chain, which I just did, and ensure that when I start numbering it, the double bond always gets the smallest number. So let us see how we can start numbering this. We have to start numbering it from left to right, because the double bond is on the left side and that is the one that has to get the smallest number. So this is how we're going to start numbering it. I put a 1, 2, 3, 4, 5 and 6. Now if you notice, the double bond lies between 2 and 1, which is the smaller one between them is going to be 1. So let's see how we're going to write this. We're going to have a prefix, root word, suffix. Now if you notice, we have two prefixes, one chloro which is at the 4th position and one bromo which is at the 5th position, and let us see how we could write it. I could write it as 4 chloro, 5 bromo, and that altogether would become my prefix. If you notice, I have 6 carbon atoms in my longest chain, so that's going to be hex. And if you notice, I have a double bond at the first position, which is going to be ene. Now this is sometimes accepted, but we need to understand that between chloro and bromo, bromo comes first alphabetically. So it's essential that you put bromo first at the 5th position and chloro second at the 4th position when you finally name the organic compound. So your final answer is going to be 5 bromo, 4 chloro, hex-ene, or just hex-1-ene. I hope you were able to understand why we put bromo first and chloro first. They've maintained a standard such that everything that comes first alphabetically is always given a higher preference while we name it. I want you to try this one. This is CH2, CH2, CH, double bond CH, this is CH2 and another CH followed by a CH3. I'm going to attach an NO2 to my first carbon. I'm going to attach a chloro to my second carbon. But between nitrochloro and the double bond, since double bond is a functional group, double bond should always get the smaller number when you start numbering it. I'll give you a couple of minutes to figure this out. Let us start numbering the carbon atom after identifying the chain. We notice that that happens to be my longest chain. I have to number it such that the double bond gets the smallest number. So let me start numbering it appropriately. I'm going to start with 1, 2, 3, 4, 5, 6, 7. I notice that the double bond lies between 3 and 4 and the smaller number between 3 and 4 is going to be 3. Let us put this together now. I'm going to have the alphabets and placed alphabetically. Nitro starts with an N, chloro starts with a C. So when I start naming it, chloro should come first at the 6th position. So I'm going to say 6 chloro and then I'm going to say 1 nitro, which becomes my prefix. My suffix would have 7 carbon atoms in it, so that's going to be hept. And my suffix is going to be an ene at the 3rd position due to the presence of a double bond. So my final answer is going to be 6 chloro, 1 nitro, hept, 3 ene. I hope that was clear to all of you. We have a couple more examples before we're done with this module of the chapter, and this is something that I want you to try again. We just enhance this and let's put a triple bond in place so that you're able to understand this better. So this compound is CH3, C triple bond C, followed by a CH and a CH3, and I'm going to attach a chloro group to one of my carbon atoms. Let's see how we can try this. Now if you notice, you have a triple bond here indicating that your functional group is going to have an ine in it because this belongs to the alkyne family. So that is going to be one clue before you begin. Now what I'm going to start doing is first identify my longest chain, and you notice that my longest chain is going to be the chain that consists of 5 carbon atoms, which I'm going to name as 1, 2, 3, 4 and 5 to ensure that the triple bond that I have gets the smallest number. So between 2 and 3, 2 happens to be the smaller number, so I'm going to number it from left to right. Now when I put the whole structure together, I have a prefix, root word and suffix. I notice that there is a chloro in the 4th position, so that becomes my prefix. There are 5 carbon atoms, so that becomes pent. And in the 2nd position, I have a triple bond, so that becomes 2-ine. So the final name of the compound is going to be 4-chloro pent 2-ine. There are certain places where you could just write it as 4-chloro 2-pentine as well, which is also accepted. Now let's look at the last one. I'm sure all of you should be able to do this much more comfortably now that we have done so many examples. So I'm going to take an example of CH2, C, triple bond C, CH2, a CH3. I'm going to attach a chloro there, another chloro to the same carbon atom, and to my leftmost carbon atom I will attach a methyl group, which is CH3. Now let us try and name this, but before that I want you to try apply all the concepts we just done. But remember something, we have a triple bond there indicating that the alkyne group is going to be the functional group. Right, let's start with the last one. Let's identify the longest chain, which is that one. We have to ensure that the triple bond gets the smallest number, and that's possible only when I number it from the right, because in that case my triple bond lies between 3 and 4 and the smaller number is going to be 3. So let us now name the organic compound with the prefix, root word and suffix. Now if you notice, there are 2 chlorine atoms attached to the 5th carbon atom. So when I write the name, I have to write it as 5,5 dichloro, and di, the word that I've just circled, indicates that there are 2 carbon atoms. We also notice that there are 7 carbon atoms in the longest chain, making that hept. And then we have a triple bond in the 3rd position, so that becomes hept3-ine. So my final answer is going to be 5,5 dichloro hept3-ine, or 5,5 dichloro3-heptine. Now just to summarize everything we've just done, there are very few steps that you need to know. The first step is to identify the longest carbon chain. The second step is to number as per the preference to ensure that the functional group always gets the smallest number over everything else. The third step is to use the right format, which is your prefix, a root word and a suffix. And then once we have all this done, we just write the name. I hope today's session was useful. I would love to hear from you guys, and then we'll share more and more videos as we move forward. All right, have a great day. Bye bye.